You know what I did?
All right, guys, let's take a look at these. 1, what'd you get? Number 1.
4 to the third times 3 times
Good.
3 to the third.
There's 3 of each.
Yeah.
I love it. Sounds a nice one to start off with. Number 2.
21 to the fourth.
I love it. So thank God you don't have to actually multiply that out. That'd be kind of gross. Okay, so don't do that. I like how there's no number 3. Is there no number 3?
Yeah.
That's neat.
No, there's no 18 or 19 either.
Oh, really?
Yeah.
I just don't like those numbers. So number 4, this kind of freaks people out sometimes, but it's almost too easy.
81.
It's 81. Anything by itself is that thing to the first power, right? 7 is actually 7 to the first power.
Did you write it 81 times 4?
No. You technically could, because it's still the right answer, but there's no reason from what it's giving you to say times 1. Yeah. Guys. Guys.
Class.
Alright, so number 5.
81.
Yeah, 3 to the 4th
71.
is 3, 3, 3, 3. Now the way I normally do this, 3 times 3 is 9, times 9 is 81. Cool. Alright, how we doing so far? Alright. Number 6 is another one that's almost too easy. 1. I don't know how many times you want 1 to the 3 billionth power is 1. Everybody alright so far? Okay. 4 squared, that's nice. 16, 4 times 4, 16. I get a lot of 8s. But be careful, it's not double 4. It's 4 squared, so 4 times 4. 8. The neat thing about powers of 10 is the power on the 10 tells you how many zeros you have. 10 times 10 is 100. That would be 10 squared. You have 2 zeros. So 10 cubed should be 1,000.
1 more zero. Right.
So 10 to the 11th power would be a 1 with 11 zeros behind it. You with me? So it'd be 1, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Cool. So powers of 10 are really nice. Some of you guys have ever done scientific notation? Have anybody ever heard of scientific notation?
Yeah.
It will be in your future. And it uses powers of 10 to rewrite really big or small numbers easily. Okay. Cool. The non-existent number 9, I like it. Now let me really try to get you guys, I think, I'm not the neatest guy in the world. I'm sure you've noticed that. But when you're doing math, you will do yourself the hugest favor if you just are kind to yourself and be neat about how you work it. And so what I mean by that is, you first identify what the idea is. So here, what operations do I have? Multiplication and subtraction. So of course, which one do I do first? So you say, okay, I'm going to do this first. Everything else in the problem, this is not a very big problem. We have larger problems coming up. But you leave everything else in the problem exactly the same, and you replace that piece with what it is. Right?
I had to mess it up.
So this is still 32, this is still minus, but what's this?
That's 24.
Yeah. And then you just finish it out.
Oh, 32 take 24. That's
Is
messed up.
Alright, you guys doing alright so far? Yeah? So what about number 11?
4?
6 minus 2.
You almost can't go wrong here. They put the division first, so even if you went straight through, you do it right. 48 divided by 8. 6 minus 2.
Minus 2, 4.
4, I love it. Sweet. Number 12. Yeah. What operation will you do in this problem last? Add. Sometimes it's good to realize that. You will definitely add last. So that means you're going to do 2 times 5, 10. The plus is still here. 4 times 6, 24. And then 10 plus 24, 34. 11. How are we doing so far? So if you would just, if you kind of organize and then underline to tell yourself, this is what I'm doing right now, and this is what it became. I mean, that's going to keep you straight. A lot of times people understand it better. They just get lost in their own work. Right? Was that 6 here, or was that, oh crap, I just put a number in between.
I do.
When we're doing our problems, what do you prefer? Vertical or horizontal for us to write them out? Or is
For
that
these
just
kind of
preference?
problems, either way really is fine. Vertically is easier to look at, but for right now, it's okay to do it in a straight line. When we start getting to algebraic equations, you really can't do it in a straight line, because you can't have multiple equal signs. And I will make a point of that when I grade your stuff. You pretty much have to do it vertically.
Okay.
But for right now, it's just simple simplification. So you can do that straight across.
If you got it in your head, and see, if you don't, you got to go vertically. Just to get
Whichever,
it.
if one way makes it better for you, do it that way. This one's not too bad. What do you do first here? Definitely in the parentheses. Now, why is this not really a question of, well, somebody would say to me, well, you said not to add before divide, Jeff, but why is that not really an issue here? Parentheses overrides everything.
Right.
It shoots it up to the top, from the bottom of the to the top.
Priority.
So this is
25
25,
divided by 5.
11.
Somebody's fantastic about that.
So same idea here. What do you do first?
Okay.
Yeah, you do this first.
Yeah. What's that for?
4. So everything else stays the same. Let me not do that, that was free. 16 divided by, and you just replace 6 minus 2 with what it's also known as. It's also known as 4. And then 16 divided by 4. 4. Good. Okay, cool, cool, cool. Here we go. Now we hit the freaky ones, right?
Yeah. Yeah, he's trying to get lost in the sauce. It's trying to get lost in the sauce, but he
Now what does that bar mean, of course?
divided.
And let me ask you this. What do we definitely do last here?
Divided.
That bar, because we understand that this is all together and this is all together, right? So you can basically look at it as that kind of problem, because it ain't nothing to do with the bottom. So what do you do with the top first? Yeah, this would be 5 times 4. Everything else stays the same. You just replace this with what it is. 6 minus 2,
Okay,
since it's in parentheses, I do that first,
right.
is 4. Cool. So effectively, I really didn't do anything. I
Right.
just used a better symbol for 6 minus 2. Better symbol is 4. Yeah.
But you don't do 5 times 6 and then 5 times
You
10?
could, and that wouldn't be wrong, but it's really easy to make a mistake. Distribution, watch. If I have this problem, do I have to distribute? No, because I can actually do this. When did distribution come into play? It comes into play when I can't. Can you do anything with that? What's x minus 2? Yellow. No. I don't know what x is. So that's why distribution came in. It says, oh, you can't do order operations? Well, let me help you out a little bit. Right? And we'll get into it when we get into distribution. When we get into distribution, I'll show you how it's not a violation of order operations. It just kind of rewrites it so it's easier to do. And then what do you do up top next?
5 times 4.
Yeah, you got to do multiply before add. So 5 times 4, 20. So again, I replace this with what it is.
27 on
Good. So I'm not done with the top. 27 over 3 is
9.
9. Good. 11. All right, 16. Okay. So that is yummy. What do those brackets mean? Where do they fall into order operations? They're still just parentheses. They just made it look different so it's easy to tell it apart from these. So I basically, this is my problem first. I got to make this into a number so I know what the hell to take away from 30, right? So it's 30 minus, and this 2 times 3 plus, that will stay the same for a while. Technically, you could do the 2 times 3, but let's just go stick strictly by the book. So what can I do inside here first?
Parentheses.
Okay. 8 minus 5, 3. And what can I do next? Exponent, good. So the 30 minus and the plus 2 times 3 is still there, right? They just come for the ride. They're waiting to see who the middle dude is.
Duke it out.
So that's 16. And I'm still not done in those parentheses yet. Let's see if we can do it all in one step. 16 plus 3 is 19 minus 6 is 13. So this whole thing is 13. So now I took this whole ugliness and I made it into a number. Now I can actually do something with it. But what can I do next? By the book. Multiply. So everything else stays the same. 30 minus 13 plus 2 times 3 is 6. Cool. Now here's where I saw a lot of people give me 30 minus 19. What mistake was made there? They added first. They thought PEMDAS A before S. No. Not like I before E. It's not. It's what as it comes. I only have addition and subtraction, so I just do it as it comes. What's 30 minus 13? 17. And then plus 6? 23. Right? And then Jim Carrey goes crazy. Do I get that reference? You seen the movie? No, you just like the Jim Carrey. He was in that movie 23. Yeah? Everything's 23. Any questions on that one? Doing all right? Okay. 17. And this really, they really try to hammer this idea home. It's almost the same format as 16. You guys see that? One thing that would really help you in math is to realize there aren't an infinite number of problems. There are just a few, and they kind of change the things around. So it's the same problem as number 16. It really is. I do in here first, then I subtract, and then I do the multiplication. It's really the same problem. So I definitely have to do in here first. What do I do first in there? Parentheses. So this is 4. And what do I do next? Yep, the exponent. 25. Good. So you could, I even tell people that really have a lot of trouble with this, cover this with a piece of paper, because treat this like it's your problem now. That's a new problem. You look at it fresh. I've got to do in here. I've got to multiply, like you said. Multiply before add. So multiply those, you get 8. And one last step to finish up that middle dude.
25 plus 8.
Yeah, add those things together. What can I do in there first? What do I have to do first?
Multiply.
Good, so I can multiply. 6 times 2. And the same problem as before, you don't do add before subtract, you do them as it comes. 50 minus 33 is 17 plus 12, 29. Okay. And real quick, this last one. Last freaky little dude with the fertilizer. So square law is 72 on a side.
Wait, we're not doing the area of the square?
Oh, I guess that is up there now. All right, this is 20. I think they're, this kind of builds it up. We'll call this number 19. I don't think it has a number on it, does it? Well, how do you find the area of a square?
Length times
Or any rectangle, really. Length times width. This is number, there's no number on it, so it's blank. The little square there. 12 times 12. 144, what would you say? Not meters, but what would it be?
Square meters.
Square meters. Because it's 12 meters times 12 meters, m times m is m squared. All right, cool. That leads you into number 20. I've got this lawn that's 72 feet on a side, it's square. How do I figure out how many square feet there is? Same idea, right? Area is length times width. So 72 times 72. Something or other, I don't know.
5,184.
5184. What? Square feet. So I don't think it's 10,000 or something. So would that be enough to have 4 bags that covers 1,200 square feet?
No.
Because how many total square feet can you do with 4 bags?
4,800.
Yeah, 4 times 1,200 is 4,800. If each bag covers 1,200, you have 4 of them, 4 times 1,200, you can cover 4,800 square feet, but your yard is 5,184 square feet. You got to go shell out some money for another bag, right? Or get a cow, I don't know. Make your own. All right. Got that just under the wire, so.
You're gonna add some flour.
All right, guys, so we're going to take a little tour, so I'm going to try to get a heady out the door. For next time, you desperately have to start trying out Chapter 1 homework.